Have you ever wondered how a massive, multi-billion-dollar national policy connects to a tiny, intricate circuit board that you can literally hold in the palm of your hand? Well, today that's exactly what we're going to do. We're going to trace the line from India's huge ambitions in electronics all the way down to the real-world engineering that makes it all possible.
So here's how we're going to break it all down. First, we'll dive into what's being called India's electronics gold rush. Then we'll look at the new workforce, the engineers who are actually powering this whole thing. After that, we're going to get super specific and look at the anatomy of a PCB, a printed circuit board, to see what they build. And finally, we'll zoom back out to connect all those tiny circuits to a massive $500 billion future. All right, let's get into it.
Okay, first things first, we have to wrap our heads around the sheer scale of what's happening here. This isn't just some steady growth. This is a full-blown national mission to build an electronics manufacturing powerhouse pretty much from the ground up.
And it all kicks off with a number like this, 40,000 crore rupees. Now to put that in perspective for you, that's roughly $5 billion US. And that's the government's latest investment into just one program, the Electronics Components Manufacturing Scheme. So what's the big takeaway here? This isn't a small bet. This is a massive, flashing sign that building a domestic electronics ecosystem is a top priority for the country.
Now, this slide really tells the story of the last decade. Just look at these figures. Overall electronics production, up 6 times. Exports are up 8 times. But the real jaw-dropper, the number that tells you everything, is mobile phone exports. A 127-fold increase. That is absolutely monumental. It shows India shifting from being a country that mainly imported phones to a major global supplier.
And all this growth, of course, has a huge human impact. We're talking jobs, lots of them. That one scheme we mentioned, the ECMS, is expected to create over 140,000 direct jobs on its own. But that's just one piece of the pie. The entire sector has generated 2.5 million jobs over the past decade. This is about building careers and changing lives.
Which naturally brings us to a really critical question. All this money, all these new factories, they need skilled people to make it all happen. So who exactly are these engineers at the very heart of this incredible transformation?
So for this next part, let's focus on the people on the ground. We're talking about the new generation of electrical and electronics engineers who are turning these huge national ambitions into actual physical products.
For these engineers, the opportunities are just exploding. This table shows you where the big money is, and it's probably no surprise what's at the top. You've got semiconductor and VLSI design. VLSI stands for Very Large-Scale Integration, which is, basically the magic of cramming millions of transistors onto one tiny chip. It's the foundation of everything, with salaries going up to 35 lakhs per year. And right up there with it, AI hardware and electric vehicles. All sectors that are directly benefiting from this national manufacturing push.
And this isn't just about a good starting salary. It's a career path with an incredible growth trajectory. An engineer just starting out might make around 4 to 8 lakhs a year, but as you gain experience, that number climbs fast. A senior engineer can be making 20 to 35 lakhs, and if you become a true global expert, you could be looking at 50 lakhs a year, or even more. The demand for real expertise is huge, and it's being rewarded.
Okay, so we know the jobs are there, the money's good, but what does the work, actually look like? What does an engineer do all day? Let's zoom in even further. From the career path right down to the fundamental task that's behind every single electronic device.
This brings us to the absolute core of the engineering work. Right here, we're going to break down the anatomy of a printed circuit board, or a PCB. This is where an engineer's idea, their digital blueprint, starts to become a physical reality.
So what even is a PCB? Well, the easiest way to think about it is like the skeleton and the nervous system for any electronic device. It's that green board you see inside your phone, your laptop, even your car. It's the foundation that holds all the tiny components and creates the little copper highways that let them all talk to each other. Simply put, without the PCB, nothing works.
And designing one is the super systematic process. It starts with a concept, which becomes a digital blueprint called a schematic. From there, the engineer has to place every single component onto a digital layout. It's almost like city planning, but for electronics. They figure out the layers of the board and then route all those tiny copper highways. And maybe the most important part, they run a ton of automated checks to catch any mistakes before they send the files off to the factory to actually get built.
And of course, they aren't doing this with a pencil and paper. They use these incredibly specialized software tools. Things like Altium Designer are the industry standard for big, professional teams. But what's really cool, and this is a total game changer, is the rise of software like KiCad. It's free, it's open source, and it makes this powerful technology accessible to everybody: students, hobbyists, small startups. It's fueling a whole new wave of innovation. All right, for our final section, let's pull the camera all the way back out. We've seen the high-level policy and we've drilled down into the nitty-gritty engineering process. Now let's connect that one single circuit board design all the way back to that grand economic vision.
And here we are, back at another massive number, $500 billion. That is the goal, the ambitious vision for India's electronics manufacturing ecosystem by the end of this decade. And remember, every single PCB designed by every single one of those engineers we talked about, it contributes a tiny but absolutely crucial piece to hitting this huge target. The micro-level work is what directly fuels the macro-level ambition.
Now, this kind of growth doesn't just happen by magic. The government has been carefully building a supportive ecosystem. You've got things like the PLI scheme, which basically rewards companies with cash for producing more. Then there's EMC 2.0, which is all about building top-notch manufacturing parks. And the SPECS scheme helps companies with the cost of setting up factories to make components right here in India. It's a whole strategy working together.
And really, this quote from the Press Information Bureau just sums it all up perfectly. The goal isn't just to make more stuff. It's about positioning India as a credible global hub for advanced electronics manufacturing. That's the vision that ties everything we've talked about together. So we've gone from a 40,000 crore rupee policy down to the career of an engineer, deep into the design of one circuit board, and all the way back out to a $500 billion economic dream. And it all leaves us with one final, really exciting question to think about. As this new generation of millions of engineers gets to work designing the circuits of tomorrow, what truly new, world-changing innovations are going to emerge from India's tech ecosystem? Thanks for joining me on this deep dive.